970, the relationship you described in part E of problem 969, which we didn't do, but we're about to talk about, is called the Pythagorean theorem. It states that in a right triangle, the length of one leg squared plus the length of the other leg squared is equal to the length of the hypotenuse squared. It can be written as an equation like this. The leg of A squared plus leg of B squared equals the hypotenuse squared. Now, a couple things that you need to write down. This is not optional. You really need to write this down because I guarantee you are going to need to know this and in other math classes as well as on tests and quizzes for us. So I'm going to show you, we have leg A and leg B here. So those are the legs of the triangle. And it does not matter which one we call A or which one we call B. You can use whichever one you want. Now, we have the hypotenuse, and the hypotenuse, if I can trace it nicely here, it's about as good as it's going to get. So the hypotenuse, there are a few things you're going to need to write down about this. So the hypotenuse, first of all, is always C. So the hypotenuse, we can never say A or B. The hypotenuse is always C. The hypotenuse is always the longest side of the triangle. And finally, the hypotenuse is always directly across from the right angle. All right. So you could go ahead and pause if you need to make sure that you get all of those copied down. Now, another way we can simplify this equation here is we can say, I'm going to color coordinate this with my triangle over here. So we could say A squared plus B squared equals C squared. So you can see my legs are in yellow and my hypotenuse is C and it's in purple. All right, let's go ahead and have a look at parts A, B, and C. It says to use the Pythagorean theorem, which is this equation we just talked about here, to write an equation for each diagram below, and then we also have to find each missing area. So for part A, I see that they have given the areas of the legs of the triangle. So since they have given me that, I know that those are going to go in spots A and B. Now they've already been squared, so I'm going to do 9 plus 34. That's going to equal C squared. Actually, it's just going to equal C because it's already squared. So 9 plus 34 gives me 43. So 43 is equal to C squared. So another way of putting this in terms of context of the problem, since we're finding each missing area, is saying 43 centimeters squared. So you do want to make sure you have those labels. Centimeters squared is very important, especially considering we are talking about area. All right, you're going to see in part B now that they have also given us the areas for the legs. So they've given us the a squared and the b squared. All right, so that means we need to find the area of that square that shares a side with the hypotenuse. So again, we're going to do 8 plus 12. That equals c squared. And 8 plus 12 is 20, which is c squared. So in terms of context of the problem, let's say 20 meters squared. So again, remember those labels. Then finally, this last one, you've got to be careful with this one. So this one, you're going to hopefully notice that the areas they give us are, they give us an area of a square that shares a side with one of the legs. And then they also give us the area of a square that shares a side with the hypotenuse. So our equation is going to look a little bit different for this one. So what we're going to do is 10 plus b squared equals 25. Or you could do b squared plus 10 equals 25. That is acceptable as well. You'll get the same answer because remember, I'm sorry, I guess we could call that a squared plus 10 equals 25. So it doesn't matter which one you use, you'll get the same answer. And that's because the legs can go in for A or B. So to solve this, I can see just by looking that 10 plus 15 is going to give me 25. So if I want to write it out proper like, I can do where I subtract 10 from each side, and I'm left with 15 equals b squared. Now in this case, in terms of labels and area, we're going to say that it is 15. In this case, we're talking feet. And since it's area, it needs to be squared. Okay, that's all for problem 970.